Hello students, here is one another question from applications of trigonometry of class 10th, and the question says if the angle of elevation of a cloud h meters above the lake is alpha and the angle of depression of its reflection in the cloud is beta, then we have to show that the height of the cloud is h into tan beta plus tan alpha upon tan beta minus tan alpha. So let's try to solve this by making a rough sketch. Suppose this is a lake and this is a point h meters above the lake, and from this point the angle of elevation of the cloud, suppose this is a cloud and this is horizontal, so this is a line of sight, this is horizontal, and this is the angle of elevation, that is alpha. And let's label this as A, B, C, and this as D, this is E. So CE is the height of the cloud above the lake, and its reflection in the cloud will be at the same height. So let's say EF is the reflection of the cloud in the lake, and from this point to this angle, this reflection of the cloud in the lake, the angle of depression is beta, and this AB is H, so this D will be equal to AB and this will also be H. So AB is equal to D is equal to H meters. Now we will have to remember that the height of the cloud above the lake, that is C, should be equal to its reflection, its the distance of the reflection or the height of the reflection in the lake, that is EF. Now in this right angle triangle, that is this one, the BCD, in right angle triangle BCD, if we use this trigonometric ratio, that is tan alpha, that should be equal to CD by BD, and if we cross multiply this, BD should be equal to CD by tan alpha. Let's suppose this is our equation 1. And in another right angle triangle, so another right angle triangle is this one, BDF. So this right angle triangle BDF, once again we use this tan ratio, so tan beta should be equal to DF by BD. Once again if we cross multiply this, so BD should be equal to DF by tan beta. And now if we check this equation, these equations 1 and 2, we see that the LHS of both the equations is equal, so the RHS should also be equal. So we will write from 1 and 2, CD by tan alpha is equal to DF by tan beta. So CD by tan alpha is equal to DF. Now DF can be split up into DE plus EF. So in place of DF we will write DE plus EF by tan beta. We know the value of D. D is H plus EF. Now EF was equal to C, so in place of EF we will write C by tan beta. So finally we have CD by tan alpha is equal to H plus CE. Now CE can once again be split up into CD plus D by tan beta. So CD by tan alpha is equal to H plus CD will remain as CD, D is equal to H tan beta. H plus H will be equal to 2H plus CD by tan beta. Let's cross multiply this. So this will be equal to CD into tan beta is equal to 2H into tan alpha plus CD into tan alpha. Let's take this CD tan alpha to this side. CD tan beta minus CD tan alpha is equal to 2H into tan alpha. In both these terms CD is common, so tan beta minus tan alpha should be equal to 2H tan alpha. So finally we have got the value of CD. CD has come out to be 2H tan alpha by tan beta minus tan alpha. So we have find out the value of CD, but we have to show the height of the cloud. So height of the cloud is CD plus D. So height of the cloud is CD plus D. We will place the values of CD and D. CD we have find out and D is H. So value of CD is 2H tan alpha upon tan beta minus tan alpha plus H. And if you take the LCM, so tan beta minus tan alpha. So this will remain as 2H tan alpha plus H tan beta minus H tan alpha. Now 2H tan alpha minus H tan alpha will be equal to H tan alpha plus H tan beta and divided by tan beta minus tan alpha. So this is the height of the cloud. So height of the cloud, in both these terms we can take H as common. So this will come out to be tan alpha, H into tan alpha plus tan beta upon tan beta minus tan alpha. This is the required height that we were supposed to find out. So the height of the cloud has come out to be H into tan alpha plus tan beta upon tan beta minus tan alpha. So this is the solution of this question. Thank you guys.